Hello everyone, welcome back to Wireless Sensors and Networks. Today we are going to discuss about media access with reduced handshake protocol, that is MERCH protocol, and flow requisition multiple access protocol, simply FAMA protocol. These two protocols are comes under the classification of contention based protocols. FAMA protocol is single channel sender initiated MAC protocol, whereas MERCH protocol is receiver initiated MAC protocol. Now let's look at the operation of MERCH protocol. The protocol does not require any traffic prediction mechanism, and the protocol exploits the broadcast nature of a traffic from omnidirectional antenna. Hence, it is used to reduce number of handshakes involved in the data transmission. MERCH protocol that uses MSCA mechanism. Once recall the MSCA mechanism. Here, two control packets like RTS and CTS packets are need to be exchanged before each packet is transmitted. Whereas in MERCH protocol, RTS packet is used only for the first packet of the stream. From the second packet onwards, only CTS packet is used. Therefore, the throughput of MERCH protocol is significantly high when compared to the MSCA protocol, and the control overhead is less when compared to the MSCA protocol. Now let's look at the data transmission of MERCH protocol. In this picture, I am going to combine two operations, MSCA and as well as MERCH protocol. MERCH protocol is compared with the MSCA protocol. Now let's look at the MSCA operation. I am going to consider the four nodes. They are A, B, C and D respectively. If A want to transfer the data to the neighboring node, definitely it has to contend with the neighboring node and it should be in the channel. If it is done, A having the data for transmission, so it is going to first send RTS packet to the neighboring node. If B is ready to receive the information from A, and it is confirming by sending acknowledgement CTS back to A. On hearing this CTS packet, the data is transferred from A to B. Now the data packet is arrived at B, means there is a data packet at point B. If B want to transfer the information to C, again it is going to send RTS and it is receiving the confirmation packet from C and the data is transferred to C. That is happen. Similarly, if C want to transfer the data packet to D, again two control packets are exchanged and then followed by the data is transmitted. The two control packets are RTS and CTS and then followed by the data. So this is the mechanism present in MERCH protocol. Now let's look at the MERCH protocol data transmission. If A want to transfer the data to the B, for the first time it is going to send RTS packet. On hearing this RTS, similarly B is also sending a CTS packet to A similar to that of MSCA. CTS1 is nothing but the CTS packet. On hearing this CTS packet, A is transfer the data to B. Now the data is arrived at B. From the second onwards, if B want to transfer the data packet to a neighboring node, it couldn't establish any RTS packet or request to the neighboring node to C. Okay, the C is going to make a confirming in such a way that it is sending CTS packet 2 to B. On hearing this CTS packet 2 by B, it is immediately transferring the data to C. Now the data packet is at C. Similarly, if C want to transfer the data packet, again it couldn't establish any request to D. Okay, the D packet means the D node is sending CTS packet 3 to C. On hearing this CTS packet 3 by C, the data is transferred to D in such a way that the data is transferred from A to D. So here the point is you have to understood is for the first time of data packet, only request is made from the A to B. From the second time onwards, there is no RTS packet from B to D. Whereas in MECA protocol, for each transmission means from A to B as well as B to C and C to D, there are the two control packets are exchanged. One is RTS and as well as CTS. Whereas in MERCH protocol, that is not happen. That means the number of control packets are reduced in MERCH protocols. And the second one is the time taken for data travel from A to D, that is also increased in MERCH protocol. That can be reduced in MERCH protocol. Okay, means this is the time required for sharing the information from A to D, and this is the total time taken by the nodes from A to D transmission of data. Okay, so that is the advantage of MERCH protocol. Now here the question is, how does the node C and D knows the information about the B status? Means how the C knows about the status of B, whether it is received from A or not. Similarly, how the node D knows about the data transmission of C, whether the data is available at C or not. For that case, for the first time of CTS packet by B, it is sending a CTS packet 1 to A. At the same time, the same CTS packet is also heard by node C. Okay, on hearing this CTS packet by C, it think that yes, B is already make a conversation with the A, so that I have to wait for some period of time. After that, the data packet may arrive at B, so and I am going to make a request to B so that I can receive the information B in such a way that the C has to wait for some period of time. After that period of time, the C is confirming by sending CTS packet to B, that is CTS2. Similarly, the same thing is happened to D. After some period of time, the D is sending CTS packet to 3 by hearing this CTS2 in such a way that the data is transferred from A to D in MARCS protocol. Okay, so in this MARCS protocol, the CTS packet carries the information about sender address, receiver address, as well as it is also used to carry the root identification number, simply RTID, so that if any malicious node can be present within the network, using that RTID we can easily eliminate, means we can easily overcome that problem. And as well as, and if any false CTS packets are initialized by or initiated by some other nodes within the network, using that transmitting ID as well as receiving ID and the root ID, we can easily overcome that problem. Okay, so that is the advantage. And when the nodes are overly loaded with the number of nodes, or the network is loaded with many number of nodes, the average end-to-end delay in packet delivery for MARCS protocol is less when compared to the MARCS protocol. And then second advantage of this MARCS protocol is, we saw the comparison between MARCS protocol of the MACA protocol. There are the number of control packets are exchanged in MARCS protocol is less, so that this MARCS protocol is also called as single handshake mechanism or single handshake protocol mechanism followed by this MARCS protocol. And also the bandwidth is being consumed for the controlling traffic is also less. Okay, and also the power consumed by the nodes is also less in this ad hoc network, because if the number of control packets are exchanged over the network, definitely duplications of control packets may heard by the nodes. Okay, and as well as a continuous request packets are receiving from the nodes, that is not happens in MARCS protocols. We are overcoming those problems in MARCS protocols, and it reduces the bandwidth for controlling the number of control packets, as well as it is going to use the bandwidth in an efficient manner. And it also uses the power efficiency also increased in this MARCS protocol. And the next we are going to discuss about flow requisition multiple access protocol, simply FAMA protocol. This protocol comes under single channel sender initiated MAC protocol. Once recall the single channel, once if a node want to transfer the data, definitely it has to win the channel. So once the node win by the channel win by the node, whatever the available bandwidth is there, the entire bandwidth is utilized by that node only. Okay, so that is single channel sender initiated MAC protocol, and the request is initiated by the sender only. So that is the meaning of single channel sender initiated MAC protocol. This FMA protocols are based on channel access discipline with consist of carrier sensing operation as well as a collision avoidance dialog box between sender and receiver. The flow requisition refers the process of gaining control of the channel, and the carrier sensing by the nodes followed by the RTS CTS control packets are exchanged. It is similar to that of the MACA protocol. There are the two variants are there within this FAMA protocols. They are RTS CTS exchange with no carrier sensing and RTS CTS exchange with non-persistent carrier sensing. If we are using RTS CTS exchange with no carrier sensing protocol or variant, that uses Aloha protocol for transmission of RTS packet, whereas in this RTS CTS exchange with non-persistent carrier sensing, simply it uses CSMA for the RTS request. That means if you are using FAMA protocol with a non-persistent, Before sending RTS packet, the node is going to sense whether the channel is free or not. The sensing of the channel that is done with the carrier sensing. Okay, if the node is free, if the channel is free, okay, in that case the RTS packet is transferred to the destination, and then on hearing this RTS packet, the receiver is sending acknowledgement by sending CTS packet. Without defining or without sensing the channel is free, the carrier is reschedules its data transmission after some period of time. Means after some period of time, again the carrier is going to check whether the channel is free or not. If the channel is free, and it is going to make a request. If it is not free, again it has to wait for some time. After that period of time, again it is going to sense the channel is free or not by sending carrier frequency. So that is happen in FMA protocol. So what we discussed here is, we focused on how the data transmission is done, or how the data packet is transferred from one node to another node within the network that uses the FAMA protocol, as well as MERCH protocol. Thank you.